Hi and welcome to E-ZTutoring. Today we are going to cover how to find the inverse and the determinant of a 2 by 2 matrix. So suppose we have a matrix A, B, C, D. First we are going to find the determinant. The determinant is a lot easier to find. Now in order to find this, all you do is you take two diagonals of this matrix. You take the first diagonal, which is AD, and then you subtract the second diagonal, which is BC. So the formula, we'll call this matrix A, and we'll say that the determinant of A equals A times D, so that's one diagonal, minus the other diagonal, which is B times C. So that right there is your formula for the determinant of a 2 by 2 matrix. So now we want to find the inverse of a 2 by 2 matrix. And that's where the determinant is going to come in handy. So we are going to do a very similar setup to this. Suppose that we have matrix A again, which is A, B, C, and D. And if we want to find the inverse of this matrix, we'll call it A to the power of -1. That's how you write the inverse. What you do is you write 1 over the determinant of A times, and then you want to multiply it by this matrix, but you need to switch around this matrix a little bit. What you do is you switch the A and the D. So A becomes D and D becomes A. And the other two, you simply put a negative on them. So C becomes -C, B becomes -B. So all I've done so far is I've simply written down the formulas for this. Written down the formula for a determinant and the formula for the inverse. So now let's go ahead and actually do both of these with some real numbers. Okay, so let's suppose we are trying to find the determinant and the inverse of this matrix right here, 1, 0, 0, 1. So first we are going to start with the determinant. And I went ahead and wrote the formulas here so we can have them handy. The determinant we know is AD minus BC, which we know is this diagonal minus this diagonal. So the first diagonal, AD, is 1 times 1, 1 times 1, minus BC, which is BC, 0 times 0. Well, 0 times 0 is simply 0. And 1 times 1 is 1. So 1 minus 0 is 1. So your determinant is 1. Pretty easy, right? Now let's go ahead and find the inverse of that exact matrix. So the inverse, we know it is 1 over the determinant of that matrix. And we know that the determinant is 1. So you do 1 over 1. And now you need to multiply this by a little bit of a different matrix. So you multiply this by the same matrix, except that now you switch this one with this one. And of course they're the same exact number, so nothing really changes. Now, what else you have to do is you have to put a negative on each of these numbers, just like this formula over here follows. Now, a 0 can't really become negative, doesn't change the fact that it's still 0. So if we go ahead and simplify this, 1 over 1 is just 1. 1 times the number, we don't need to write that 1. So we just have the matrix 1, 1, 0, 0, and look at that. Nothing changed. So the inverse is the same. Let's go ahead and do one more example. Okay, so now suppose that we have a matrix with -5, 6, 2, and 3. Now we want to find the determinant of this matrix. So if you guys remember, we simply take the first diagonal, right? We take this diagonal right here, which is -5 times 3, -5 times 3. And then we subtract the other diagonal, which is these two numbers, 6 and 2. So 6 times 2. And keep in mind, we are following these formulas exactly as how they're written. So simplifying this down a little bit, this gives us -15, and this gives us 12. So the determinant is -27. Okay? So now suppose that we want to find the inverse of this matrix. Now you always have to do the determinant first since it's in the formula. So the inverse is 1 over the determinant, which is -27, times the matrix. Now if you remember, we have to switch these two numbers. So we switch the 3 and the -5. So the 3 goes here and the -5 goes here. And then we have to put negatives on the other two numbers. So the 6 becomes negative and the 2 becomes negative. Okay? There is one more step that you can do. And what you can do is you can take this number in front of the matrix and you can distribute it into the matrix. Whenever you multiply a number into a matrix, you have to distribute it to every single number in that matrix. So this matrix becomes 3 over -27, -6 over -27. Two negatives cancel, so we just have 6 over 27. Same with the 2, so we have 2 over 27. And we have 5 over 27. 3 over 27 actually simplifies. And this simplifies to 1 over 9. And all the others don't simplify. So this right here would be your final answer. And this is the inverse of that matrix. So I went ahead and covered the formulas and 2 examples with real numbers. I hope you guys have a good understanding of determinants and inverses now. For ACT or SAT tutoring help, be sure to visit my website, www.e-ztutoring.com. Thank you and good luck.